All right. Last but not least, or maybe sort of least because it's an optional bonus question, there's a set of tasks to do for a linear mixed effects model. So if you remember, these are kind of the bonus lectures I gave you at the tail end of the semester. These pertain to this particular data set, which was not, this has nothing to do with German. This is collected by my PhD student, Mohammed Al-Samani, who is working on Swahili for his dissertation. So he collected, when I first set up this problem, we actually didn't know what it told us, so we just kind of like threw it out there and kind of learned something from it by just making an exercise here. But Mohammed collected this data from Swahili speakers in two different locations in Africa, Mombasa, which is a city in Kenya on the coast of the Indian Ocean, and Zanzibar, which is a Tanzanian island in the Indian Ocean, just a little over 200 kilometers away from Mombasa. So they're pretty close, but in Zanzibar, close geographically, but they're very different kind of culturally and historically as well. So in Zanzibar, people mostly speak Swahili as an L1, while in Mombasa, Swahili is mostly spoken as an L2. So they're also distinct linguistically, which is where this question is coming from. Okay, so Mohammed collected this data because he was interested in finding out whether or not there's a contrast between aspirated and unaspirated stops in Swahili. Based on some spoken Swahili samples he found online, he wasn't sure if, number one, there was any meaningful contrast between stops labeled as aspirated and unaspirated in the language at all, and number two, if such a contrast was cued more by VOT in the language or more by F0. It was actually ambiguous from the samples he found. So in addition to VOT, the explanatory point here is that in addition to VOT generally being higher for aspirated stops than for unaspirated stops, F0 can be higher for aspirated stops than for unaspirated stops. And these two cues kind of get conflated, and that can sometimes lead to tonogenesis in a language. So so he's going to try to find out if there was something going on with VOT that corresponded to this distinction, or maybe if there was something going on with F0 that corresponded to this distinction. So he traveled to Kenya and Tanzania, had all sorts of interesting adventures, and then had Swahili speakers there read off the names of pictures they saw of various objects. So they just saw a picture of something and then said, we're supposed to name it. And then those names of those objects and animals began with what were supposed to be either aspirated or unaspirated stops in Swahili. He then measured the VOT the speakers produced for each initial stop, along with the initial F0 in the vowel that followed the stop. He also made these measurements for a number of other items we won't analyze here, and it took Mohammed a while to finish his dissertation because it took an enormous amount of time just to kind of collect this data. In all, he recorded and measured over 7,000 stops in each location, so that involved quite a bit of work. We probably should have tried, well, that was even after we simplified it. That's how much he did. But anyways, here are all of his measurements for this data set. So number one, what do these data fields tell us? There's a kind of subject identifier here that you don't have to worry about too much. There is also an utterance, which is the order of utterance produced by each participant in the experiment. These don't go, not all the numbers are going to be in here because we're cutting some of the stuff out to make this a little simpler for everybody. Number three, there's the word produced on each trial, also including the number of repetition of that word. So this is just a Swahili word, and as you can see, they're kind of written like they might make a distinction between like aspirated and unaspirated, but we don't know for sure if that's the case. Okay, so then he has VOT for each trial, like here. Then he has an F0 measure for each trial here. Maybe I can make that bigger as well. I don't know if I want to do that. Then he has the particular stop, the transcription of the stop at the beginning of the word. So that could be either unaspirated, like here, and then aspirated, like here. There's also some chuz, some post-alveolar stops, which could be aspirated or unaspirated. Here's the ch, the aspirated ones. So then there's also the phonation type for the stop, according to Swahili literature. Here's the place of articulation. These are bilabials. These are the post-alveolars. They're either unaspirated or aspirated. He's got the gender of the speaker. It's female or male. And then he's got a location, Mombasa or down at the bottom. It's going to be Zanzibar. Okay, coolio. So your job, should you choose to accept it, is to use a linear mixed effects model to attempt to answer Mohammed's research questions number 1 and 2 above. So task 0, for all the tasks below, analyze what the speakers in the two different locations do separately. So split the data frame up into separate subsets for the Zanzibar and Mombasa speakers. That shouldn't be too hard, but it's going to be crucial because they're living in two different linguistic worlds, right? Okay, so task number 1, build a VOT model, and we're going to do this kind of following the steps of the tutorial that I walked you through. So it can be helpful to look back at that tutorial and the example code for linear mixed effects models that you find there, and then also that I've posted to the course website in the lecture, right? Okay, so as a first step for this, you want to create a null model of VOT measures for the production data. These null models should treat both subject and word as random effects. And at this point, just consider random intercepts in the models you build and don't include any random slopes because we don't need to go there yet. So these are your 2 random effects, subject and word. And these kind of nicely are basically 2 of the first fields in the data set too, right? Okay, so task 1B is to look at different possible explanatory fixed effects for the data. So we're going to look at gender, we're going to look at place, and we're going to look at phonation. So place of articulation is what I'm referring to there, not the city in which it's being spoken, because we already split the data up that way, right? So phonation is kind of the really interesting research question that we're worried about here. With gender, we know this will probably come into play for F0. We don't know if it'll come into play for VOT. And we know there's an effective place on VOT as well, so we kind of want to consider that as well. So we're going to create separate mixed effects models where each of these factors is the only explanatory factor in the model. So we start out with the null one, and then we create 3 different models with only one factor each in them, only one fixed effect each in them, one of those 3. And then you test each of these one factor models against the null model to see if it makes an improvement over what we started with, over the null model that we began this task with. Report the results of these 3 tests in the format that Bodo Winter recommends in his tutorials. If any of the factors you tested significantly improves the null model, then keep it in the model and proceed to task 1C. If you found more than one factor that it significantly improves the model, keep the one factor that accounts for the most deviance in the data, i.e. has the highest chi-squared score, and then proceed to task 1C. It's a little bit like choose your own adventure, but it's more like the data chooses the adventure for you, because in task 1C, you kind of go through the process again and see if you can do better than just the one factor model. So if you've gotten to this point, you've got one factor in your model that explains the data to some extent, add on to this one factor model. So keep that factor in it and then add the other 2 factors to that in 2 separate models. So add on to your one factor model by building 2 new models, each with one of the 2 remaining factors you're testing. Then determine whether either of these 2 factor models is a significant improvement over the one factor model. Again, report the results of these tests in the format described in the tutorial. If you find a second factor that improves on that one factor model, then keep it in the model and test whether the interaction of these factors improves on the 2 factor model. So for instance, if just going in order here, if gender is the best factor from this step in the process, and then when you do task 1C, you find that place is the best thing to add on to gender. So then you got gender plus place, and then also look at the interaction between gender and place. So these 2 factors independently and also their interaction. That's what you do down here. Continue on in this way, adding potential explanatory factors and interactions to the model until no further additions make a significant effect or significant improvement on your existing model. So you can't do any better by adding something new. Report the results of all the tests you run and also report the structure of your final model. Just so, tell me, you've got subject and word as these random effects, and then also add on those, tell me what the significant fixed effects are as well. Okay, task 1D is don't do this, but don't run any post hoc tests on the model you develop. We don't need to go there for this, but do tell me what the coefficients of the model are. If you walk through the lecture, there's a pretty simple way to do that. And use them to lay out some basic interpretations of how each factor in the model is affecting the VOT measurements. Just like if one's going positive, one's going negative, just tell me what that means, basically, in terms of VOT. Okay, note that it might be a little tricky to interpret any interactions in the model, but just give it your best shot. This is a bonus question after all. I don't want you to stress out too much about it, but it will improve your grade if you do it. Task number 2 is do all that we just walked through for F0 as your dependent measure. So in case this wasn't clear before, we're going to be building VOT models here for the Mombasa speakers and the Zanzibar speakers separately. In task 2, we're going to build models separately for Mombasa speakers and Zanzibar as well, but the dependent measure is going to be F0. And we're going to use the same method we applied in task 1. Okay, so just to give you a heads up, like I said, when I first got this data, it was just raw off the presses, and we hadn't really processed it as much as we probably should have. Still don't have time to do that 2 years later, so I'm just going to tell you, you can process it. Some of these F0 measures are 0, which is the pitch tracker screwing up, basically. So with that in mind, or getting fooled by whatever, get rid of these 0 hertz F0 measurements. That's your first step. So filter those out for both sets of speakers. And then go through the whole process of building a model like we did before. Report the results of those significance tests you run. Report the final structure of your model. And then tell me what the coefficients of that final model are. And tell me how they explain each of the factors, or how each of the factors and interactions in your final model affects the measures of F0 in the data frame. Basically, everything you did for task number 1, just do it again for F0. And then finally, for task 3, just answer the basic research questions. So now you have these models. You can get a sense of how to answer those questions. Is there a meaningful difference between aspirated and unaspirated stops in Swahili? And if so, which acoustic cues are used to signal this distinction? Could be VOT, could be F0, could be both. Or maybe it's none. I don't know. So also, are there any differences between the 2 varieties of Swahili, Mombasa and Zanzibar, in terms of which factors affect VOT and F0? Are there any results in the analysis that you find surprising, given what we know about F0 and VOT? Right. You could, if you really want to, check out what Muhammad has to say about this in his dissertation, or you can just do the work yourself. Either way, it's a bonus. And I want you to send me your R consoles as usual when you send in your homework, but send them into D2L. And you can let me know if you have any questions by the usual route. And once you're done with that, that's it for the semester, unless you're in 660 and then you owe me a paper too. But you already know about that, so I'm not going to say anything further about it right now. Okay, that's it for now. See you somewhere down the road.